All right, everyone, let's get started on IP-directed broadcast over VXLAN. This is the agenda. I'll go through an overview, go through the use cases, details and caveats, how to configure it, some best practices, how to troubleshoot it, and provide a demo and close off. So, overview of IP-directed broadcast over VXLAN. As we know, broadcasts are normally contained within a subnet. So this feature will actually forward broadcasts across different subnets. Before 10.10, you could do IP-directed broadcasts with non-VXLAN networks before 10.10. But 10.10 now adds support for IP-directed broadcasts over VXLAN. What does this mean? Basically, you can see here on the left, I have a source device here on a 10 subnet, and I have a destination device on a 12 subnet, and they're connected with a VXLAN tunnel. So if you do not enable IP-directed broadcast over VXLAN, if this host sends a broadcast to 12 subnet, the VTAP1 will not forward it. Okay? And this host will not receive it. But when you enable that, IP-directed broadcast over VXLAN, when 10.1.10.15 sends a broadcast to the 12 subnet, this device will see it, will actually receive it. So that's the main point of this feature. So these are the three supported platforms for this feature. You can see 6300, 6400, and 8360. Use cases. So from what we've seen, it's used as WIC on LAN for software distribution in large networks. You can see here, I have a WIC on LAN server on VTAP1 on the 10 subnet. I have WIC on LAN clients on the 12 subnet and 13 subnet on different remote VTAPs. So IP-directed broadcast from the WIC on LAN server will be sent to subnets 12 and 13 to distribute the software. We've also seen financial and banking environments required for stock-related applications. So they can enable this for their applications on different subnets. Details. So take note, it's disabled by default. It must be enabled on SVIs. So this is an example. On the left, I have the source SVI VTAP1 with the source device. On the right, I have the destination SVI VLAN 12, the destination host that's supposed to receive the broadcast. So you actually enable IP-directed broadcast on VTAP2 SVI 12, VLAN 12. You enable it here so that this subnet can receive it. There's no need to enable it on VLAN 10. It's always the destination SVI that is configured with IP-directed broadcast. You can see they're actually communicating via the L3 VNI because it's different subnets. So this broadcast will be received over the layer 3 VNI from the 10 subnet. Another example, you can see VTAP1 has both the source and destination subnets SVIs. So 10 and 12 are on VTAP1. VTAP2 also has VLAN 12. So the broadcast is actually sent via L2 VNI for VLAN 12 and mapped to VNI 12 here, this example. So in this case, because the destination is also on VTAP1, you basically enable it on VTAP1 SVI 12. Okay, so you always enable it on the destination. If the destination exists here, similar to the source, you just enable it here, and this remote VTAP will receive the broadcast as well because it has a layer 2 VNI. This is what a packet capture looks like for IP-directed broadcast over VXLAN. You can see the source on the 10 subnet, destination is 12 broadcast address 255, and it's over VXLAN. It's being forwarded over VXLAN. You can see the packet capture. Caveats: be aware, it's IPv4 only because IPv6 doesn't utilize broadcast. We've gone through this example before, right? Where the VTAP1, okay, has a source and destination basically. So you enable IP-directed broadcast on VLAN 12. So because of this, right, be aware of this caveat. Because it's only supported on 6300, 6400, and 8360, VTAP1 has to be these three platforms, one of these three platforms. VTAP2 could be something that's not supported like A325, 8400, or even 10,000. So that has been tested and validated by QA. This will work. And VTAP 2 can actually be a third-party VTAP, right? Non-CX. It might work, but has not been validated by QA because this feature is actually dependent on being enabled on this SVI. Right? That's why it will work, even though these three platforms do not support it. So this is a caveat to be aware, right? Configuration-wise, this is how it looks like on the destination SVI that are connected to hosts that are supposed to receive the broadcast. Just enable IP-directed broadcast in the SVI. How do you verify? You do show IP-directed broadcast. You will show as enabled. It's also possible to add ACLs on the SVI connected to the source, which sends the broadcast. Why do you want to do this? If you want to limit the broadcast from being sent. Okay. This is an example of the ACL that's applied inbound, routed in on the SVI connected to the source. What we're doing here, this example is basically deny the broadcast from this source device to these different subnets. You want to deny them, but permit to everyone else. This example. So you can do this if you want to limit the broadcast to be sent everywhere. Best practices. So you should only enable IP-directed broadcast only on required SVIs. And ensure that all remote VTAPs with the same SVI have it enabled. So you can see here, VTAP 1 on the left is connected to the source. I have subnet 12 on two different VTAPs here. They have layer 3 VNI because different subnets. So this example, you will want to configure IP-directed broadcast on VTAP 2 and VTAP 3 SVI 12 because these have the destinations. Once you enable them on both, you'll both receive the broadcast over the layer 3 VNI from this source. In this case, you can see the destination SVI is also on VTAP 1, connected to the source, so you actually enable it on here. There's no need to do it here. But if you have the gateways here, you can actually enable it. It doesn't cause any issues, but it doesn't accomplish anything. So for consistency, basically, you really want to configure the same thing, right? Even though it might not be used here, because you might have another SVI connected here, you want to broadcast out. So just enable it all. Troubleshooting. So what do we recommend for troubleshooting? Basically, have your topology diagram ready with all the details, like the loopback addresses, the SVIs, the ports connected to the source and destination. Okay. Make sure you know what tunnels, what VNIs are being used. So you want to check, this is the troubleshooting flow. Check the VTAPs actually support IP-directed broadcast over VXLAN. That's the first step. Next, you can verify if that's configured correctly on the correct VTAP and SVI. Next, on the source VTAP, you want to make sure that you see the broadcast traffic. Right? If the VTAP doesn't see it, that means there's a problem with the source device. Next, at the destination VTAP, you want to check if it sees the broadcast traffic. So make sure the correct software is loaded. If someone tries to enable it, like in the older version, right, it will not work. And you want to configure it correctly. So you want to refer to the best practices. At the source VTAP, how do you check? You enable mirroring, okay, so that you can see what your source device sends. This is a sample config sent to a packet capture device. So if the source VTAP doesn't see the traffic, the source device could be the problem. At the destination VTAP, you do the same. You want to mirror. If the source VTAP sees it, but destination VTAP doesn't see it, there's one way you can check. So before you do all this packet capture, you want to make sure the VXLAN tunnels are up and functioning for unicast and other bump traffic. Make sure everything else works before you even check IP-directed broadcast. Right, next, I'll move into the demo portion. This is my demo setup. On the left, I have a 6300 number 1. On the right, I have a 6300 number 4. Okay, this is my source device that I'm sending a broadcast out on VLAN 10. I also have VLAN 12, a device connected on the same VTAP, and another device on VLAN 12 connected on a remote VTAP. So I will enable IP directed broadcast on VLAN 12 SVI on 6300.1 because that's where you want the broadcast to be sent, and it will be forwarded across the L2 VNI to this device. So that's my demo setup. Let's move on. Let's take a look at the devices. 10.15. So that's the source device you can see here. 10.15 IP. Okay, so that's the source. Let's look at the next device. We have 12.15. That's this device. And finally, we have a device here, 12.16 on the right. Let's enable the packet capture. Here, I just want to look at the traffic from 10.15, right? So right now, I'm not seeing any traffic here on the Windows device. I'll start the packet capture as well. You shouldn't see any broadcast coming in because I've not started it. Okay, so let's start the broadcast. From the 10 to the 12 subnet is being sent. Let's verify. Nothing seen on the Windows. Nothing seen on the remote device connected to the VTAP. Next, let's check under VTAP on the left. Show IP directed broadcast. You can see it's not configured. And this is the SVI connected to the subnet 12 here. Okay, it's not configured, not enabled. Let's enable it. IP directed broadcast. IP directed broadcast. Right now, you can see VLAN 12 is enabled, and the broadcast has started coming in into the Windows device. You see from the source to the destination, broadcast is being sent. And on the remote side, you should see it coming in soon as well. You can see now, yep. So both devices on the 12 subnet are seeing the broadcast from the 10 subnet device. That's the demo. Resources wise is the RFC, and thank you for the session for that.